Before we were here, the world was different. Tonight, we walk quietly through the Cretaceous rivers. If this finds you tonight, subscribe and tap the bell. Each night, a new ancient world will find you again. Close your eyes, breathe slowly, and let the ancient world carry you to sleep. 112 million years ago, the world was warmer. The continents were drifting into new shapes. Africa had not yet pulled fully apart from South America. Where the Sahara now stretches, broad rivers once moved slowly. The air was heavy with moisture and breath of ferns. Tropical heat held the days in a steady warmth. Mangrove-like trees rose along the riverbanks. Cycads and early flowers spread across the plains. Dragonflies the size of small birds drifted above the water. Fish moved in dark schools below the surface. Pterosaurs glided in slow circles overhead. On land, dinosaurs walked the floodplain in heat. Some browsed with their heads low to the ground. Others stalked the riverbank in search of fish. All of them, sooner or later, came to drink. And in the water, something larger was waiting for them. Not a fish, not a marine reptile. Something older in shape than the dinosaurs themselves. In this world, Niger was not a desert. It was a vast green floodplain laced with rivers. The Elraz Formation was being laid down, layer by layer. Sands and silts settled into the slow channels. Bones and teeth were buried in those sediments. 112 million years later, we dug them up. But tonight, in our imagining, the rivers are still moving. They are warm and shallow in places. Deeper and darker in others were the current pools. Logs and fallen branches gather at the bends. Tropical light filters through the canopy above. Ferns crowd the lower banks in soft green tangles. Insects hum above the still pools at the edges. The breath of the river is everywhere in the air. Small lizards skim the warm rocks at the water's edge. Frogs call to one another from the shallows at dusk. Fish rise quietly to the surface for floating insects. Lungfish bury themselves in soft mud during dry weeks. Turtles drift slowly with the current at midday. This is a river world, alive in every layer. Near the middle of the channel, a shape rests. At first, you might mistake it for a log. Long, dark, motionless against the slow current. Then you notice the slight ridge of armored back. The careful breath at the waterline. The two dark eyes set high on the broad skull. You are looking at Sarcosuchus Imperator. The name means flesh crocodile, emperor. Paleontologists chose those words for a reason. From snout to tail, it measures roughly 12 meters. That is the length of a city bus. Its weight is estimated near 8 tons at full size. Heavier than a small forest elephant of today. The skull alone is 1.5 meters long. As long as a tall adult human is tall. Inside that skull, are about 132 teeth. They are conical, slightly curved, evenly spaced. Each is sharp at tip and broad at base. They are designed to hold, not to chew. The snout itself is elongated and narrow, closer to a modern gharial than a Nile crocodile. At the very tip is something unusual. A rounded bony swelling called the bulla. It is hollow inside with thin walls. Its purpose remains debated among paleontologists. Some have suggested it amplified low calls in the water. Others believe it carried a display structure of soft tissue. A few imagined a sense organ for underwater pressure. We do not yet know for certain, only that it sat at the front of the snout. Around Sarcosuchus moves a world of other creatures. Along the riverbank walks Suchomimus tenerensis. Its name means crocodile mimic, and the resemblance is striking. A theropod dinosaur with an elongated crocodile-like snout, almost 11 meters long, balanced on two muscular legs. A low ridge of neural spines runs along its back. Not the tall sail of its cousin Spinosaurus. A subtler shape, like a soft hump catching the light. Its forelimbs are long and end in great curved claws. Its mouth holds roughly 100 conical teeth. It hunts the same fish that Sarcosuchus hunts, but it works from the bank rather than the water. A fisher with feet sharing a fisher of waters. They tolerate each other in long, uneasy stretches of quiet. Further from the river moves Nigersaurus ticadi, a sauropod, but unlike the giants you may picture, only 9 meters long and around 4 tons. Its neck is held low, almost parallel to the ground. Its mouth is wide, flat, and surprisingly square, like the head of a vacuum cleaner pressed to soil. Inside that mouth are over 500 tiny teeth, arranged in long working batteries that wear and replace. Nigersaurus is a ground-level browser. It clips short vegetation as it walks slowly forward. Its skull bones are unusually thin and delicate. Some are so thin you can almost see through them. This is a creature shaped by diet, head to spine. Higher on the floodplain stands Ouranosaurus nigeriensis, an iguanodontian walking on 4 legs with option of 2, roughly 7 meters from snout to tail. Along its back rises a row of tall neural spines. They may have supported a sail or a muscular hump. Either form would help shed heat in the tropical days, or store fat through leaner seasons of drought. Its snout is broad and duck-like at the tip. Its hands carry a small but distinctive thumb spike, a relic of its iguanodontian family tree. Ouranosaurus browses the ferns and the soft new shoots. It comes to the water only at the safest times. These are the neighbors of Sarcosuchus. They are not its prey at every meeting. Over time, every one of them will come too close. The river is a place no land creature can avoid. Heat builds in the open plains throughout the day. Thirst becomes a deeper need than caution. Every animal must come to drink, again and again. And Sarcosuchus is always waiting in the slow places. Its rhythm is one of patience, hours long. It can hold position for half a day, if needed, breathing slowly through nostrils raised just above the surface. Its body is hidden by the river's color and motion. Algae sometimes grows on the older armored scutes, making the back of the animal almost invisible. Only the eyes betray its position. Often the eyes seem only like reflections on the water. In the evenings, the sky above the river turns amber. Insects rise in slow drifting columns. Fish surface again to feed on what the air offers. Sarcosuchus moves a fraction closer to the bank. Not yet hunting, only listening. Listening for the footfall of something larger than fish. A herd of Nigersaurus passes upstream of the pool. A young one slips in soft mud and falls behind. The current carries Sarcosuchus a few meters closer. It does not strike yet. The young one regains footing. The herd moves on through the failing light. Sarcosuchus drifts back to its midstream resting place. There will be another evening and another. Time for a creature like this is a different thing. Now we leave it for a moment and travel forward. We will return to Sarcosuchus, but the world moves on. 30 million years pass in the time between these scenes. Africa has separated cleanly from South America. A wide Atlantic Ocean fills the gap between them. In North America, a shallow inland sea has opened. Paleontologists call it the Western Interior Seaway. It stretches from the Arctic down to the Gulf Coast, splitting the continent into two long land masses. One to the east, called Appalachia in this era. One to the west, called Laramidia in this era. Along the shores of this seaway, deltas form and dissolve. Rivers carry warm sediment down to the brackish margins. Mangrove-like trees crowd the estuarine shallows. The climate is humid and tropical to subtropical. The Campanian stage of the Late Cretaceous is unfolding. Roughly 82 to 73 million years ago. The continents look almost like the ones you might recognize, but the inhabitants are very different from anything alive today. And in these warm coastal waters, a new giant rose. Its name, when we found it, captured what we felt. Deinosuchus, the terrible crocodile in Greek and Latin. Its first remains were found in North Carolina, 1850s. More complete specimens later came from Texas and Mexico. Even later from Mississippi, Montana, and New Jersey. All along what was once the Western Interior Seaway. Deinosuchus rugosus is the most studied species. Two further forms are now known from western coastal deposits. Together they spanned much of the seaway's long edge. In length, the largest specimens reach roughly 12 meters. Weight estimates fall between 5 and 8 tons. Some studies suggest larger maximum sizes for outliers. The skull alone measures about 1.5 meters. At first glance, similar in scale to Sarcosuchus. At second glance, very different in shape. Where Sarcosuchus had a narrow snout, this is broader. Where Sarcosuchus had piercing teeth, this holds two kinds. At the front of the mouth, teeth are pointed. Toward the back, they grow rounder and stronger. Blunt at the crown, almost like worn molars. These are bone-cracking teeth in their structure. They appear designed to break thick bone in their bite. Paleontologists have found the proof of this in fossil bones. Hadrosaur vertebrae bearing tooth marks of the right shape. Some bones show repeated bite punctures from one event. Others show healed wounds, meaning the prey escaped. Either outcome tells us what Deinosuchus was doing. Studies by David Schwimmer in 2002 laid the foundation. Later work in 2009 quantified the tooth marks. Cossette and Brochu revised the systematics again in 2020. Each new paper adds a fraction more certainty. Around Deinosuchus moves a different cast of creatures. On the coastal plains walks Albertosaurus sarcophagus, a tyrannosauroid but smaller than its famous cousin. 8 to 10 meters long, gray seal in build. Long muscular hind legs and reduced two-fingered hands. Its skull is deep and powerful, but narrower than T-Rex. Its teeth are serrated, curved, and shaped like blades. Recent fossils suggest at least partial feathering on its body, a coat of fine filaments along the neck and back. It lived a little earlier than the great Tyrannosaurus, but it overlapped in time with Deinosuchus in coastal forests. At the river, the two predators came close. One on the bank, one in the water. In broad herds across the floodplain moved Edmontosaurus, a hadrosaurid, a duck-billed dinosaur of the Late Cretaceous, 12 meters from snout to tail, around 4 tons. Its mouth is broad and ends in a duck-like beak. Inside that mouth are hundreds of small grinding teeth, arranged in dental batteries that replace as they wear. Edmontosaurus walks usually on 4 limbs, but can rise. Its tail is long and laterally compressed for slow swimming. Its body is heavy, its limbs robust and strong. In great herds, it moves through the coastal lowlands, browsing on conifers, ferns, and early flowering plants. At the river margins, the herds slow to drink. This is where the world holds its breath. Deinosuchus moves through the brackish water in long, slow patrols. Unlike Sarcosuchus, it tolerates salt water for some hours. Salt glands on its tongue manage the excess. It can pass between river and shallow sea with ease. Estuarine reaches are its favored hunting grounds, where the river slows and meets the warmer sea. Sediment hangs in the water, hiding shapes below. Tides shift the depth a little throughout the day. The animal positions itself by what the tide reveals. A trunk-deep pool at low water becomes ambush range later. Mangrove-equivalent trees lean over the channels above. Their roots make tangles where smaller prey hide. Above the water, pterosaurs of several kinds glide and call. On the bank, smaller lizards and amphibians move through shadows. Insects swarm in clouds above the still pools at dusk. Deinosuchus breathes slowly at the surface, almost invisible. Only the line of its eye ridges shows above water. Below, The body is enormous and still in soft current. Its life cycle is unusually long for any reptile we know. Growth rings and fossilized bones suggest 50 years or more. Adults grew slowly across decades, never stopping fully. Most of that time was spent in the favored estuary. Territories were large and almost certainly defended. Rivals were probably challenged with low underwater calls, with body bulk shows along the surface during quiet hours. The strongest adults claimed the deepest ambush pools. Younger ones held the narrower upstream waters. Hatchlings would have been near helpless at first. Born from large eggs buried in warm sandy mounds. Mothers may have guarded the nests as living crocodiles do. Many hatchlings never reached their first dry season. Predators took them from air and water and bank. Those that survived grew slowly into giants over decades, and some grew into the largest crocodyliforms ever known. On the same continent walked the ancestors of T-Rex. Other ancestors led toward the great Tyrannosaurine line. Their fossils sometimes appear in the very same formations. A few of those bones bear marks of crocodiliform bites. We do not know if Deinosuchus killed the tyrannosaurids themselves, or only scavenged carcasses brought by the river. Both possibilities remain on the table for now. Either way, the relationship was not what most viewers expect. The riverside of the food web was not safe. Even apex land predators came to the water at last. Now we return to the Sahara of 100 Mia. Light fails along the broad, slow river of El Raz Formation. Sarcosuchus has not moved from its midstream position. Its breathing is so slow that the surface barely ripples. Its body temperature drifts a degree with the water. As a large reptile, it relies on surroundings for warmth. Warm water in the day, cooler water in the night. It conserves energy by not moving when not needed. Stillness is the most efficient strategy for an ambush hunter. Even the smallest motion would alert prey at the bank. A Nigersaurus herd has moved toward the river for hours. Their low silhouettes pass between the cycads and the ferns. Their thin skull bones rustle softly as they browse. A young female has been falling behind the group. Her steps are a little less certain than the older. Her thirst is greater because she carries less reserves. She breaks toward the river ahead of the rest. Sarcosuchus does not move, not yet. Its eyes track the young Nigersaurus from the skull side. Its river position is already correct for an ambush. Years of patrolling have taught it the safest drinking spots. Animals always come down to drink at certain favored places. The young Nigersaurus reaches the bank and lowers her head. Her wide vacuum-like mouth pushes into the soft mud first. Water rises into her mouth and over her gum line. She drinks slowly, then deeper, in long, calm pulls. The current moves it a meter closer, almost effortlessly. It drifts silently closer, meter by meter. The breath at the nostrils slows further. The body sinks until only the eye ridges remain visible. 5 meters between the predator and the drinking sauropod. Then 4, then 3, then 2. The strike, when it comes, is faster than the eye. The water explodes upward in a sheet of muddy spray. 1.5 meters of skull rises at speed. The jaws open to their full 130-degree gape. Then they close on the throat of the young Nigersaurus. 132 conical teeth find soft tissue. The bite force is enormous, but does not crush bone. Crushing was never the purpose of these teeth. The purpose was holding, and the hold is now absolute. Sarcosuchus does not let go. It cannot let go. Its body rolls in the water with a controlled twist. The Nigersaurus is pulled off her feet by the rotation. Her thin neck and skull cannot resist that immense torque. She is pulled under in less than 3 seconds. Her family upstream raises their heads, then keeps drinking. There is nothing they can do for her at distance. The river settles again into its slow brown rhythm. Beneath the surface, Sarcosuchus has not yet finished her. It maintains the grip and waits for struggling to end. Drowning is the most reliable kill an aquatic predator has. No risk of escape, no risk from a kicking limb. The hold is held for 2 or 3 minutes, until the body of the young sauropod stops moving entirely. Then Sarcosuchus carries her gently to a deeper pool. In that pool, the carcass will be torn apart slowly. Conical teeth cannot chew. The body must be twisted apart. Each piece is shaken free with another rolling motion. This is called the death roll in modern crocodiles. It is the way an animal without chewing teeth feeds. It likely used the same technique, scaled to its size. A roll from a 12-meter body moves immense water. The feeding takes most of the night to complete. Other crocodyliforms gather slowly at the edges of the pool. Smaller relatives wait for what the dominant animal leaves. Smaller fish and lungfish scavenge the scraps that drift. Bones sink slowly into the soft mud at pool bottom. Some will be preserved over the next 100 million years. Centuries later, those very bones may be found again, each carrying the small, detailed evidence of this single night. A tooth mark here, a puncture there, a healed wound. Paleontology is, in part, the reading of these records. From bones we cannot see the hunt, only its shape. But the shape is enough to know what once happened. By dawn, Sarcosuchus has eaten only part of the carcass. It will not need to feed again for many days. A meal this size sustains for weeks at low rate. It returns to its midstream pool and resumes the stillness. The river resumes its slow brown rhythm under rising heat. Suchomimus picks at the remaining scraps on the bank. Even the apex hunter cannot eat every piece alone. The neighbors share what is left, in order of size. A few hours later, even the smallest scavengers have gone. Only soft fragments and smell of mud remain at edge. The herd of Nigersaurus moves on through the inland plain. They do not know what happened to the young female. Over time, the herd learns where rivers narrow dangerously, and over generations, instinct shapes them around the danger. Territories among adults were probably long stretches of river, each adult owning roughly 1 kilometer or more of channel. Younger animals lived along the margins of those territories. or in smaller side channels and warm, shallow pools. Disputes were settled by display rather than direct combat. The body bulk shown along the surface was warning enough. A larger animal could be seen at its back alone. A smaller rival would retreat to a less contested water. Fatal fights between adults were probably rare and disastrous. An injury at this scale could end any participant's life. Bite force at the head was a last resort. Most of life was waiting. Most of life was rest. In rainy seasons, rivers swelled and flooded the plains. New ambush opportunities arose in the temporarily widened banks. Trapped fish gathered in pools as the floods receded. Stranded young dinosaurs sometimes appeared along the shrinking margins. Sarcosuchus moved out into the floodwaters during these weeks, then settled back into its midstream pool when river returned. In dry seasons, channels narrowed and prey grew scarce. Many smaller relatives slept in burrowed mud chambers. Lungfish wrapped themselves in slime and slept under the mud. But Sarcosuchus, at this scale, could not retreat into hole. Its size required water, always water. In the worst droughts, it sought the deepest remaining pools. Sometimes traveling overland between channels in slow march, a 12-meter animal moving across damp grass at midnight, then sliding into a new river system with quiet relief. Through these long, calm years, the species held its place at the top of the food web of riverine ecosystems. The largest crocodyliform of its time, perhaps of any time, it coexisted with the fish eaters and the sauropods. With many smaller relatives and many smaller prey, it was a fixture of the Aptian-Albian world for ages, until the climate began to shift again. But that part of the story comes later tonight. For now, we leave Sarcosuchus in its quiet midstream pool. The river moves on, the light fades and returns again. The animal rests, half aware of the water around it. Its breath barely lifts the surface in the failing afternoon. Its eyes follow the smallest motions along the distant bank. Time, for a creature like this, is a longer thing. Now we travel forward to the cousin on another continent, to the larger sibling of the same family of giants, to the river that fed into a different sea entirely, to Deinosuchus in the warm coastal waters of Laramidia, and to the hunting style that left such bone evidence. The western interior Seaway is widest at the equator. Brackish estuaries crowded its shoreline for many miles. Tide ranges are gentle but constant throughout the lunar month. Salt-tolerant trees lean over the channels in quiet rows. Sediment-rich water moves slowly through the brackish lagoons. In one lagoon, the predator held territory for decades. The adult is over 10 meters long and 6 tons. Its bony armor along the back has thickened with age. Some of the scutes carry small green growths of algae. Older specimens become almost indistinguishable from sunken logs. The eye ridges sit high on the broad skull always. They are the only visible part of the animal above. Even in clear water, the body is hidden by mud. The river current shifts the surface and obscures the shape. A heron-equivalent shorebird walks within meters of the animal. It never knows what is just beneath the still surface. It hunted with patience as great as its African cousin. But the bite, when it comes, has different mechanical purpose. The skull was broader, the jaws heavier, the hinge stronger. At the front of the mouth, teeth pierce soft tissue. Toward the back, the teeth are blunt and rounded. These rear teeth crush rather than slice or puncture. Bite force estimates vary widely across the published studies. Some place it near 18,000 newtons, others much higher. The highest estimates rival the bite force of Tyrannosaurus rex. Even the lowest estimates are higher than any modern crocodile. Such force makes possible something Sarcosuchus could not do: break bone in a single hold. A femur, a vertebra, a long limb shaft. A snapped bone tells the predator prey will not escape. This is a different hunting model than the slow drown. Faster, harder, more efficient against large prey. Deinosuchus could take prey too heavy to drown by hold. Multi-ton hadrosaurs walked the floodplain in great herds. Without bone-cracking bite, none of them would be edible. On a humid morning, a herd of Edmontosaurus approaches lagoon. There are perhaps 20 animals in the loose-knit group. A mix of adults and juveniles, browsing as they walk. They have moved since first light, finding fresh shoots. Now they slow as they approach the brackish water margin. Adults drink first, lowering their broad duck-like snouts. The juveniles push between them, eager and impatient. One young Edmontosaurus wades a little deeper than the others. Its hind legs sink into soft mud at lagoon bottom. It pulls one leg free, then the other with effort. In the slow, brackish water 6 meters away, it shifts. Its body rotates a few degrees to face the Hadrosaur. Its tail moves once, gently, to position the head correctly. The surface above the predator remains undisturbed in morning light. The strike from Deinosuchus is similar to that of Sarcosuchus, but the closing jaws are heavier, more crushing in force. The mouth opens fully, then closes on the hind leg. The femur of the young Edmontosaurus snaps with the bite. A sound like a heavy branch breaking carries over water. The young Hadrosaur cannot stand, escape, or return. The herd, alerted by noise, retreats in a heavy stampede. A few adults turn and bellow but cannot reach her. The water around the predator clouds with blood and mud. Deinosuchus carries its prey into deeper water with a pull. Beneath the surface, it twists the body to silence struggle. In the brackish depth, the young Hadrosaur stops moving. Deinosuchus settles to the bottom with the carcass and grip. Then begins the slow work of dismantling the animal slowly. Tooth marks left now will outlast the predator by ages. Schmidt in 2009 measured many such tooth marks on bones. The pattern of paired punctures matches Deinosuchus' tooth spacing. Some bones show one event with healed margins around punctures. These represent attacks the prey survived for a while. Others show no healing at all. Those were lethal events. A few specimens carry marks consistent with later scavenging. Where bone shows post-mortem teeth scrapes near edges and ends. Together these traces sketch a clear picture of behavior. Deinosuchus was an active predator on large dinosaurs. Not only a scavenger, not only a fish eater, a hunter. Hadrosaurs were its primary recorded prey by bone evidence. But other large dinosaurs may have been taken at margins, possibly even early tyrannosaur cousins. In rare encounters, the riverside of food web was no safe place. Adult Deinosuchus hunted in patient long shifts of waiting, likely with rest periods on shaded banks during cooler hours. Like modern crocodilians, it would have thermoregulated carefully, moving from warm shallow to cool deep water through day, hauling out onto mud banks under the tropical morning sun, sliding back into the lagoon when temperatures grew too high. Body temperature would have moved between roughly 26 degrees Celsius and perhaps 33 at the warmest peak of the day. Wider extremes would have been managed by water and shade. A reptile of this size could hold body heat long. Even after sundown, it remained warm long into the night. Slow metabolism meant slow loss of heat to cooling water. Its breeding is reconstructed from related living crocodile species. Eggs were likely laid in warm sandy mounds on banks. Females may have guarded the nests through incubation. Some sites in fossil beds show hatchling-sized bones nearby. Once hatched, the juveniles entered an extremely dangerous world. Birds and other small reptiles took many in first weeks. Larger crocodyliforms could prey on the smaller ones. Even adult Deinosuchus may have eaten unrelated juveniles. Cannibalism is well documented in many modern crocodile species. Survival to 1 meter in length was already an achievement. From there, the animal slowly entered the lower predator tier. Decades later, it might claim a stretch of estuarine water. Life pacing at Deinosuchus scale is hard to describe. Days passed in long stillness with brief moments of action. Months passed between major feeding events for the largest adults. Years passed between any significant change in territory. A single large Hadrosaur could sustain an adult for weeks. Body fat reserves grew slowly during the rich summer months, then sustained the animal through leaner, cooler periods. In good years, growth continued, slow and steady. In hard years, growth slowed but rarely stopped entirely. Each bony scoot of the back recorded these years. Each tooth replacement marked one of the long, calm decades. Other large reptiles shared the same brackish ecosystems. Smaller relatives moved through the upstream waters of rivers. Mosasaurids glided through the deeper offshore reaches of the Seaway. Plesiosaurs of several kinds patrolled the deeper waters. Sea turtles of huge size paddled through the warmest currents. Bony fish, ammonites, and smaller hunters filled the middle. On the surface, pterosaurs of several genera glided overhead. Each animal occupied a slightly different niche in the web. Deinosuchus held the niche of estuary apex predator. Nothing else could break a dinosaur bone in one bite. Nothing else patrolled the river-sea margin at this scale. Specialization made it powerful. It also made it fragile. In warm summer evenings of late Campanian, the lagoon settled. Insects rose in slow columns over still water at dusk. Pterosaurs returned to the trees along the bank to roost. Edmontosaurus herds drifted inland to safer browsing. It remained, motionless again, in its favored ambush pool. Its breath barely lifted the surface in deepening amber light. Its eyes followed the smallest motions along the distant bank. Time for a creature like this was a longer thing. In these slow, rich years, the species held its place. until the Seaway itself began to change, decade by decade. Climate is the deep tide beneath every story of extinction. In early Cretaceous, the world had been warm and stable. Ocean levels were high, polar ice small or gone. Tropical conditions reached far into both northern and southern latitudes. These warm tides created the broad rivers Sarcosuchus needed, but the tides did not hold. They never do. Around 100 million years ago, conditions began to shift. The late Albian to Cenomanian boundary marks a clear transition. Sea levels changed, rainfall patterns moved. Continental drift gradually altered the wind and current systems. Africa was pulling more fully apart from South America. The Proto-Atlantic widened, carrying new currents to both. Inland river systems began to fluctuate more dramatically by year. Some channels dried completely in the longer, hotter summers. Others flooded too violently for the slow-moving pools to last. It needed broad, slow, stable rivers to survive. Without those rivers, the species could not find hunting ground. The last fossils come from the late Albian rocks. After that boundary, the genus disappears from the fossil record. Other crocodyliforms persisted in the African rivers afterward. Smaller, differently shaped, less locked in habitat, they survived the climate shifts that drove the giant away. In the smaller ones lay the ancestors of modern crocodilians. Sarcosuchus left no descendants in any living lineage today. Its branch of the crocodile family tree ended in time. A specialized giant cannot outlast the loss of its habitat. Smaller, flexible cousins can survive what their giants cannot. This is a pattern that runs through all of paleontology. The bigger and more specialized, the more vulnerable to change. Sarcosuchus exemplified the rule by its disappearance. When the rivers narrowed, the River King could no longer feed. For 30 million years, the giant niche emptied. Smaller forms hunted smaller prey in narrower waters. No animal in this size range filled the ambush role. Then, in the late Cretaceous, the niche opened again. Continental shifts created shallow seaways at low latitudes. Coastal estuaries spread across what is now North America. The Western Seaway, in particular, created brackish margins. Warm, humid coastal conditions favored large reptilian growth. Into this opening came the ancestors of Deinosuchus. They grew larger over generations, filling the empty role. By the Campanian, Deinosuchus had reached full size. The estuarine megapredator was once again present on Earth, but this time on a different continent and family. Convergence is one of the most beautiful patterns in evolution. Different lines find the same answer. Deinosuchus and Sarcosuchus were not closely related at all. They simply both became giants of brackish or river ambush. Deinosuchus too had its time and a closing edge. The Western Seaway began to regress in late Campanian. Sea levels fell, estuaries shallowed, and shifted north. The vast brackish margins supporting the species began to shrink. Hadrosaur populations also moved with the changing environments. Some prey populations grew, others moved out of reach permanently. By early Maastrichtian, the species is harder to find. Its last reliable fossils come from this declining late period. Climatic conditions for the giant alligatoroid were running out. Then the asteroid arrived at the very end of Cretaceous. 66 million years ago, That single event ended much. Non-avian dinosaurs disappeared from the fossil record entirely. Many marine reptiles vanished alongside them in the same century. Pterosaurs and ammonites disappeared. Families ended. Most relatives also died, though some smaller forms survived. It had probably already disappeared before the asteroid fell. Its absence in Maastrichtian rocks suggests earlier end, but the broader family did not survive in giant form. What survived the end Cretaceous was smaller and quieter. Cousins of modern alligators and crocodiles lived on in rivers, none at the scale of Deinosuchus or Sarcosuchus. The giant niche emptied for the second time in family. In the long, quiet years that followed, mammals slowly grew. Birds spread into the empty niches of the small theropods. Eventually, a few crocodiles grew larger again in tropical rivers, but none ever again reached the 12-meter Cretaceous scale. Modern saltwater crocodiles top out at 6 or 7 meters. Today's largest crocodiles are half the length of giants, and less than a quarter of its mass in adulthood. The age of truly giant crocodyliforms is over for now. A modern Nile crocodile shares no genes with these. They are not direct ancestors and descendants in any line. Sarcosuchus belonged to the family Felidosauridae, a long-snouted line of crocodyliforms now entirely extinct. Modern crocodiles belong to the family Crocodilidae. They evolved much later from a different stem ancestor entirely. The shape today is a different answer to similar problems. A long jaw, armored back, eyes high on the skull. These traits arise in any animal that hunts at waterline. The body plan is a convergent answer, not heritage. Sarcosuchus was the answer to an earlier version of it. Deinosuchus was the answer to a slightly later version. Today's crocodiles are the smaller, more flexible answer of now. When we see a modern crocodile, we see this lineage. Not the same animal as Cretaceous giants, the same outline, a creature shaped by water and patience and slow current, eyes high on skull, long snout, armored back, the hunting strategy of stillness, ambush, and the slow drown. Some things in evolution become so well-tuned they recur. The crocodile silhouette is one of those recurring shapes. A success the world keeps inventing in slightly different forms. These two species were giants at unprecedented scale. They each existed for ages in warm rivers of time. Each ate dinosaurs as part of an ordinary feeding routine. Each disappeared when the rivers that fed them disappeared. Each left only bones and tooth marks behind to find. In the museums of today, their fossils are displayed full length. Visitors walk past the long-mounted skeletons and stop. The 12-meter length is hard to grasp at human scale. Viewers compare it to a city bus or long truck. Some compare it to 2 cars parked end to end. None of these comparisons truly capture the animal as such. A creature like this is not a vehicle, not skeleton. A patient, slow hunter in warm water for many ages. It was a fixture longer than mammals have been dominant. It was a familiar shape to dinosaurs coming to drink. As familiar as the river itself, as bank, as heat, its presence was simply part of the Cretaceous river geometry. When the last Sarcosuchus settled in its pool, none saw. When the last Deinosuchus stopped patrolling, no one took note. Each ending was quiet, in the way of deep time. Slowly, individuals stopped appearing in old waters. Younger ones could not survive to adulthood in changing waters. Older ones reached natural ends of long lives without replacement. A few decades passed in which the species was rare. Then a few decades in which it was effectively gone. The rivers ran on without them, unchanged in obvious way. Fish still swam, dinosaurs still drank at the bank. Smaller relatives still occupied the slower side channels. But the great ambush pool was simply empty now. A few older dinosaurs may have noticed the change briefly. Then even they passed on, and the memory was lost. From the perspective of geology, this entire story is brief. Sarcosuchus existed for perhaps 10 million years in range. Deinosuchus existed for perhaps another 10 million years. Combined, the two species spanned 40 million years of Earth. Mammals have dominated land for 66 million years. So the great crocodyliforms lasted nearly as long as mammals. Not a small slice, that is most of an age. They were not failures. They were successful for very long. They simply did not survive into the present world. Few specialized giants ever do. The world moves on, and what remains now are bones, and the marks left, and the slow reconstructions of scientists who study time. Tonight, as you breathe toward sleep, those rivers are gone. The Sahara is dry sand, and Niger is desert today. The western interior Seaway has drained from North America. The forests and lagoons of Deinosuchus are now plains. The Eldorado Formation lies under sand and rock and wind. Only in fossil sites do we find traces of giants. Only in published papers do we hear their formal names. Only in slow imagination, like tonight, do we walk together. In every river today, a smaller crocodile waits at bank. In every estuary, a related cousin patrols the brackish margin. These are the descendants of the survivors, not the giants. They carry the body plan, but not the Cretaceous scale. They live mostly in warm areas where their ancestors lived. They hunt fish and smaller mammals, and occasional larger prey. Their lives are slower than ours, longer than they appear. Some reach 70 or 80 years in their warm rivers. A few are larger than most casual observers ever guess. In each moves a fraction of deep time we walked. Each carries forward a quiet ancient solution to ancient problem. How to wait in warm water for world to come. How to be still until stillness is most useful skill. How to rest, hidden in the slow current of rivers. These are skills giants knew that their cousins still know. Skills that ask nothing of speed or noise or shine. Only patience, stillness, and the quiet wait. A way of being the world has carried for eons. A way that softened the Cretaceous rivers each dusk, and that softens our own world's rivers each evening. Now, tonight, the river outside your window is quiet. Your room is quieter still in the soft late hour. The Cretaceous creatures have rested for 66 million years. They are not watching you. They wait at no bank. The slow ambush hunter rests in stillness without effort. You can rest in stillness too, with even less effort. Your breath rises and falls in its own slow rhythm. Like the breath of the river, over the long bend. Nothing is needed of you tonight except the slow breath. Let the warm rivers of the deep past keep company.